The average weight of a machined part is 475 grams with a standard deviation of 5 grams. What is the probability that a randomly selected part from the manufacturing line would weigh at least 482 grams? I'll start this problem with a picture of the normal curve for these machined parts. The weights of these manufactured parts is likely to be normally distributed approximately. All right, so the average weight is going to be the mean, mu, the standard deviation has the symbol sigma. Those are two things we want to identify in the problem. Now for a normal curve, we want the mean to go in the middle. So let's put the 475 in the middle. We'll draw one standard deviation above the mean and one standard deviation below the mean, and to calculate those we'll be doing mu plus sigma and mu minus sigma. So we're going to want 475 plus 5 here. That's going to be 480. And on the left we'll do 475 minus 5, just to give us a good picture of what's happening in this normal curve. If we want, we can also draw the mean plus 2 times the standard deviation. That could go right here. And then on the left, we'll do mu minus 2 times the standard deviation. So we'll get 485 and 465. Now let's identify where the cutoff boundary is that the problem is talking about. They're talking about a part weighing at least 482 grams. So that's going to be a boundary that's located around here between 480 and 485. We can shade the area that they're describing. That would be all the parts that are at or above a weight of 482. So they're describing a right tail here. We have to find the z-score for that 482. And there's going to be a formula to use for that. Formula will be z equals x minus mu over sigma. That's the boundary location minus the population mean divided by population standard deviation. Alright, so the boundary that we have for our problem is 482. The mean is 475. And our standard deviation was claimed to be 5. Let's do this on calculator. I get a z-score of 1.4. We can now go back to our curve and fill in information about the z values. We've already got a nice scale for the x's. When it comes to z's, we have a z of 0 at the mean, a z of 1 for one standard deviation above the mean, and a negative 1 for one standard deviation below the mean. We'll have a 2 at the 485 and a negative 2 at the 465. But the z that we're really interested in right now is the z that goes along with the 482. According to the math, that's going to be a 1.4. Now that I know the z-score of that cutoff boundary, I could go and look up the area that corresponds to a z of 1.4. I could do this with a number of methods. I could use tables, or an online app, or a calculator. So I'll just use an online app. I'll search for a normal distribution calculator. A few different apps will come up. I might try this first one here, onlinestatbook.com. It has a picture of the normal curve, and we're going to be able to fill in our mean and standard deviation. Now we have the option of just plugging our z-score into this box right here. 1.4 was the cutoff. That's a nice picture of the area of the tail that we need. And it tells us down here that the area is 0.0808. With this particular app, we do have the option of changing the mean and standard deviation to match the values given in our problem. So if I wanted, I could put 475 and 5. And now we can see the x values match what I had drawn by hand. However, when we find our area of the tail, we now want to put in an x value rather than a z. So I could put in 482, and we can see that now it's shaded the correct area for our problem, and it gives us a 0.081 as the area. And so that's going to be the answer to this problem, 0.0808. Now you do have the option of changing this to a percent form. We know that the probability of x being greater than 482 is 0.0808. Or in other words, the probability of z being greater than 1.4 is also 0.0808. If we take that decimal and multiply by 100%, this will change it to percent form. And we'll now have 8.08%.